I just started my new recording. All right, so we're moving on to problem number 8. This one is pretty simple. We've got triangle STU, okay, triangle STU right here. It's shown in the coordinate plane below. So you got S, you got T, and you've got U, okay. And then they say triangle STU is transformed, okay, which you guys know, this is a simple translation, where XY moves to X plus 4 and Y minus 2, okay, in the image transformation where triangle S prime, T prime, and U prime, what are the coordinates of S prime, okay? So all we really care about here is working with S and doing a translation on that, all right? So since they tell us that S, all right, S, as you guys can see, is the coordinates are 2, comma, -6, and we're just adding 4 to the X coordinate, and we are subtracting 2 from the X coordinate. So if we're adding 4, we say 2 plus 4, and then we've got -6 minus 2, and that translation is going to be 6, comma, -8. And right there is our answer. Okay, and again, we just moved 1, 2, 3, 4, and then we went down 2. So that's going to be our new point right there. So that was a simple translation, 6, comma, -8. We're just adding 4 and we're subtracting 2, adding 4 to the X coordinate and subtracting 2 from the Y coordinate. All right, so now let's see. Next problem. So the next problem says the vertices of triangle SRT are these coordinates, which we already have those laid out. All right, so S, R, and T. A reflection across the line Y equals -X plus 11. So now we're back into our slope-intercept equation, okay? So -X, so that's our slope. So our slope here, 1 second. Oh, that's fine. So they give us this equation here. And this is Y equals -X plus 11. So my slope from this is going to be -1 over 1. And my y-intercept, okay, or my b, right, is going to be plus 11. So I start with my y-intercept. I'm going to go up 11. That's my first point for my line. And then I've got a slope of -1, a rise of -1, and a run of 1. So I go down 1, down and over 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 1, all right, down over 1, down over 1. So I'm drawing my line, all right, down and over 1. So now I'm going to create my line of reflection. Not bad, okay? So what they say is the same translation as 5 units to the right and 5 units up. Now, I want you guys to jump to this because what it's going to do is it's going to give you drop downs, all right? So we got 5 units to the left, 5 units to the right, and 5 units. So let me highlight that in purple. So I want you guys to do, this is where we're going to end up. So let's start with this translation of 5 units to the right, 5 units up. So if I just use I'll use green here. 5 units to the right, 1, 2, 4, 5, and 5 units up, 1, 2, 3, 4, 5. That is going to be my R prime. All right, so I'll make that point nice and big. And I do the same thing to T. So I go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. All right, and then I do the same thing with S. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. All right, and so I got S prime, I got T prime. All right, and I've got R prime, and we will fill in this shape. Maybe. So we've got two reflections, a reflection across this line, right? And then another reflection. So what the answer is that they gave us a line that has the same slope, right, as an option. And they use 16 as our starting point. So if I just took this line, all right, Control C, Control V, I put that up here. Maybe, maybe not. And I just draw that down. So it looks like I've got about the same slope. All right. So what would happen is this would reflect over and then it would reflect again. So this is one there. So the answer here is y equals negative x plus 16. And the reason why that works is because we are moving perpendicular here, and 5 units to the right, 5 units up. So again, we've got a slope of -1, and because we're doing 2 reflections, we're going to have a slope of 1, and that was the 5 and 5. So that's how that works. So we're gonna choose a slope that is perpendicular. All right. So our answers there are gonna be y equals negative x. And again, we're matching slopes there, so I've got to highlight that. We're going to match our slope there. We're going to match our slope there. And the translation is perpendicular. But again, we're just rotating through. We're reflecting and then reflecting again. Okay, so the next one is actually pretty easy. This one right here. The transformation that maps each triangle in the XY coordinate plane to a congruent triangle. So again, congruent, all right, when they tell us congruent, we know that that's going to be a rigid transformation. And our rigid transformation we have translations, which all these appear to be, okay? But if you notice, this, if our points are going from xy to 1 over x, all right, so if our points were 2, 1, we'd be going to 1 over 2 and 1 over 1, all right? So the triangle would be getting smaller at that point in time because we've got we're going half the distance. All right, so that's not correct. Here, we've got a change in dimensions, 2 times x or 1/2 times y, okay? That is also changing the dimensions, which is not congruent, so we can eliminate that one. Here, y is actually going to get bigger because the y coordinate is going to x plus y, so that's not correct. And here, what we've done is we're just moving our points, okay? This essentially is, we're using a line of transformation where y equals x. Well, no, not necessarily. But everything is, if you notice, our x's do not change because they don't have a coefficient. They're not getting larger. So this is a skew translation, all right? And it stays the same. So that's the rigid congruent triangle, all right? That one, D, would be the answer to that one. All right, and let's take a little break here. Stop.